All right, so rewriting should be like a breeze. My expectation is you fly through these questions. They're easy, gimme questions, okay? Your base, and I did choose one that was both the same number. Sorry about that. This base will be the base of your exponent. The answer is your exponent. And then what you're taking the log of is your answer, okay? Vice versa, rewriting it in logarithm. This becomes your base. So log, whatever the base of your exponent is the base of your log. You are taking the log of this guy. And it equals the exponent, because that's your answer for logs. So rewriting should be very simple. Use one to do the other. You have them both on the test. So check your work with what you have. Same holds true of these. You're really solving for what the exponent is. So you're saying 2 to what power equals 1 over 32. Remember, if it is a fraction, your answer is going to be negative. 2 to what power equals 32 would be 5. But it's in the denominator there, so this is going to be a negative exponent. Negative 5 would be my answer. Expanding, if you need to rewrite them, log base 7 of this whole group to the 1/3. Remember, 1/3 can come out in front of this group. You have these can be separated by addition. And so you have each one of these, all they've done is they've multiplied by 1/3. You can either say times 1/3 or over 3, I don't care, as long as you expand it. Condensing, your coefficients become your exponents when you condense, and then your addition would move to multiplication. So you would have your 3 to the 24th, and I don't know why they switched order doesn't matter. 3 to the 24th power and multiplied by 2 to the 6th power, or these can be reversed. I would have written them differently. Don't know why they switch them sometimes, but they do. So expanding and condensing should be a gimme as well. All right, these are really simple. Don't miss easy points on these. I will say on the quiz, which I'm going to hand back to you before you leave, I saw a little bit of some switching for some of these, so just pay attention to them. You have different types of interest, so you will have different word problems, and they will be separated like they are on your quiz review. The first type is, do you know the formula, right? That's really what I'm asking here. Your account balance equals what you invest times 1 plus your rate over the number of times it compounds raised to the number of times it compounds times t. Or if it's continuous, looks like this. So they invested. They're asking what the account balance is. What will the account balance be if they invest $4,334? Sorry. 1 plus 0.05 is my rate. It compounds 6 times per year, raised to the 6 times 20 years. And then you really just a matter of plugging it in and giving me the answer, if it will give it to me, but it won't. All right, so you should get $11,732.32. Remember, if I'm asking for dollars and cents, I want 2 decimal places, right? The second one down here, they again are asking for account balance, so we don't know the account balance. We know we invest $57.33, e to the rate of 0.5, 8 years is what we're multiplying that rate by, $8,552.63. Solving equations. Remember, you have to have only one log here. So like for number 32, you actually only have a log. You can go ahead and divide by that -10, right? Divide by the -10 on both sides. Log base 8, and this -9p is in the log. And now we can actually use our base 8. Take both to the base 8. It cancels here. -9p equals 8 to the 4th power. Divide by that -9. And you get this crazy big number. You do want to make sure it works. If I plug in this crazy big number to this, it's -455 times -9, so it is a positive inside my log. So it works. Because you can have extraneous solutions here, as we'll see from one of those. I don't remember which one it was. But you can possibly have an extraneous. In this case, you don't. When you plug it back in, you are taking the log of a positive number, so you're good to go. But if you plug it in and you're taking the log of a negative number, that does not work, and you could have extraneous. For something like number 37, we have 2 logs. You must condense first. Do not put that base 6, okay? That is the number 1 error on these. So condense them using your condensing rules. My condensing rules say that this subtraction is going to go to division. So log base 6 of 8 over 3x equals 1. Now I can do a 6 here and cancel that guy out. I have 8 over 3x equals 6 to the first power, which is just 6. And now I can solve. Remember, if what you're solving for is on bottom, you can actually just flip both sides. I feel like it's the easiest way to do it. So you can flip this side to 3x over 8, flip this side to 1 over 6. And now you can just really multiply both sides by 8/3, right?
Did you cross multiply?
Yes, you can cross multiply. It's a ratio. So you can say 3x times 6 equals 1 times 8. You end up with this guy right here, 0.4444. You'll notice these are all to 4 decimal places, which is what your logs will typically tell you to do, round to the nearest 10,000ths. That's 4 decimal places. All right, so just make sure that we're getting rid of whatever is with our base. Add it over, divide. Number 1 mistake here is people go straight to trying to get rid of that 11, okay? You will mess up if you do that for this one or the one prior. Always get this by itself before you do your log. Always get a log by itself before you do your exponential base, okay? Remove everything that's with it before you do those shortcuts to get rid of it. All right, and then we get into word problems. I pulled one from this because this is similar to one you're going to have on your test, where you're going to have to use a log. And then I pulled one from your separate handout so that you can just see both types of equations. All right. So for this guy, Cody invests $5,601 in a savings account with a fixed annual interest rate of 2%, compound continuously. How long will it take for the account balance to reach $7,120.27? You can have, you will potentially have to find your number of years for continuous or for a certain number of times a year, okay? You might have to use either one of those. This is a continuous, but you could potentially do it with the other one as well. I will not make you find rate, so I think there's one of them where it's asking for rate, where it's compounded a certain number of times a year. I'm not going to make you do that one, but you may have to do it where it's either continuous or a number of times where you have to find the years. So just think about what they gave you. In this case, they gave you your account balance. They gave you your initial investment. This is continuous, so I'm going to use e to the r. My rate is 0.2, and I do not know what my t is. So when you have something like I'm solving, this is just like what we just solved for in the prior section. We have to get the e by itself first. That means I'm going to divide by the 5601. So I am left with this 7,120.27 over 5601. You notice that I didn't actually go ahead and do that division yet, because if you round within the process, you are going to be really far off by the time you get to the end. Because think about it, logs go to the 4th decimal place, bare minimum, and that's rounding even of itself. And so it's better just to put it all in when you're done. To get rid of that e, I take the natural log of both sides, right? So now I have the natural log of this guy right here. Oh, and I wrote it backwards. This is 27 over 5601. And now over here, these cancel, 0.02 times t. So in your calculator, we're going to divide both sides by this 0.02. In your calculator, you can do natural log, open parentheses, 7120.27 divided by 5601, close parentheses, divided by 0.02. And then you're going to round, because it's number of years, 12 years. So you should be able to put all of that in your calculator, and then at the very end, round to the number of years. If it says in how many years, Unless it tells you to round to a decimal place, you can round to the closest year. Okay. So this one is from your 3-4. This is a little bit different. Exponential decay. Remember, this is a continuous, like we did with the half-life and like we did with the I think it was a chemistry problem that we did it with. Okay? So this is continuous. So you are going to use your like PERT type formula, right? When it says continuous. All right? Your when you look at something like continuous, it's like a cooling of a temperature. This is the continuous function. Why is cooling continuous? Well, it doesn't start at 68 degrees and then jump to a different degree. It's continuously cooling little by little, okay? Do you understand why cooling of temperature is a continuous function and not something that would jump, as opposed to compounding every 6 months? Every 6 months, it does a boom, a compound. 6 months later, boom, compound, right? This cooling is just happening continuously. So this is going to be a continuous. You're going to use this same function that you would have used for continuous compounding, but in this case, it's actually going down. Temperature is going down, correct? So basically what they did is they gave you what the temperature is, the current temperature, okay? The current temperature is 55.3 degrees. 7 minutes ago, it was 68.7. All right, so what you can actually say is, well, it currently is 55.3 degrees. It started out at 68.7. We don't know the rate, but we know it took 7 minutes to get there. So I really need to figure out the rate, don't I? I need to figure out the rate. So I'm going to do that using that same process I just did. I'm going to divide by that 68.7. I'm going to take the natural log of both sides. And then I'm going to divide by that 7. So this guy right here is going to be my rate. Now I will tell you how I do this. I leave it just like that, okay? And I actually pop that into my rate when I do this to solve, because I don't round it all when I'm doing these problems. So I think that's actually what it shows you when it shows you the crazy little thing that it does. It says, in how many minutes will the coffee cool to 40.6? Well, if we use this guy up here, we now know the rate. This guy represents our R. Okay? Now we're looking for time. All right? So for this particular one, I'm going to say, well, I know what I want it to be. I want it to be 40.6. I know it started out. There's 2 ways you can do this. They want to know how many minutes from now, right? So what I do, just so I keep the same formula here, is I just do where it started 7 minutes ago. And then when I find this, I'm going to subtract 7 minutes from it. Does that make sense? Or you can plug in what it is now, 55.3. And it's the same cooling rate because you're starting at a different temperature. But just keep in mind that you solved for 7 minutes ago. Does that make sense? So 68.7 is where I was, e to this r. And I'm going to put this whole guy up here, that whole r. T is what I'm solving for. All right? So I'm going to do the same process. Divide by that 40.6 equals e to this big old number here times t. I'll rewrite it in just a second. Natural log of both sides. So natural log of this guy equals the e's cancel that big rate to the t, and then divide by that big rate. So my time is going to end up being this natural log divided by this guy. All right? You're going to get something larger if you do it this way, and you're going to have to subtract that 7. So just keep that in mind when you do this guy here. Something like this. You have to, where did I start? Where am I finishing? Type of thing. But either way, you should get the right answer. And I think, if I look correctly, 10 minutes. 10 minutes is what I got when I did this one. All right. So if you look at your answer key, it will have your 7 in there because it expanded the 7. But if you do it the other way, you're going to get your, if you just subtract 7 from what your answer is. I think you end up with like 17 here, and then you have to go back and say, I got the wrong one, right? Because you started further back than what they're asking. So it's 17 minutes from the 68 degrees, but it's only 10 minutes from the 55 degrees. If that makes sense. All right.